going to be working on mathematical patterns. So let's start with a pattern. So this is my pattern. It keeps going. What we want to do is we want to be able to describe this pattern mathematically. We can do that by first writing a recursive formula. And with a recursive formula, each term relates to the next. So for a recursive formula, each term relates to the next. Or we could write an explicit formula. And in an explicit formula, it just describes how to find the nth term. So it just tells me how I'm going to find the nth term in the sequence. So what we're going to do first, we're going to practice writing a recursive formula for this pattern and then writing an explicit one. So let's start with the recursive. To get a recursive formula, we need to think about a sub 1. Where do we start? A sub 1 represents the first term in the sequence, which in this case is 36. A sub 2 represents the second number. Now, how did we get a sub 2? Well, we took a sub 1. Hopefully you noticed that we added 3. Okay? How do we get a sub 3? How do we get the next one? Well, you take a sub 2, the number you had before, and you add 3 to it. A sub 4, you're going to take a sub 3 and again add 3. If you wanted to find a sub n, what you want to do is you want to take the number before a sub n. So if a sub n is this number, what's the number right before n? Well, it's 1 less than n. So it's going to be a sub n minus 1. And we're going to take that and add 3. This is my recursive formula. A sub n equaling a sub n minus 1 plus 3. What it does is it relates the first term down here, and every term after is related. So when you state your recursive formula, you need to state a sub 1 and state a sub n. Let's write an explicit formula. So for an explicit formula, we just go straight to what is a sub n. So if I want to find the fifth term in the sequence, I just plug a 5 in for n and we would know what it is. So for this one, it works a little bit differently. We want to think to ourselves, okay, what is n? What term are we in? What is n? Then we want over here, we want our function. What are we going to do to n? And over here is going to be our outcome. So let's think about the first term. So if your nth term was 1, my outcome was going to be 36. What we're going to do is fill in the middle part in just a little bit with what we're going to do to n to get 36. So if my next term in my sequence was 2, I'm going to get 39. Oops. If the next term in my sequence were 3, I'm going to get 42. I eventually want to find out if the next term in my sequence were n, what am I going to get over here, and what's the part in the middle going to look like? So let's think. To get from 1 to 36, what do I do? Well, over here you notice that to get from 36 to 39, we add 3. Okay? So if I start with 36, in this first case, am I going to add 3 to it? No. Let's think back here. For this one, if I take 36, am I going to add 3? Yeah. Over here for this one, if I start with 36 and I want to add 3, how many times am I going to need to add 3 to get to 42? Well, I'm going to have to add 3 twice. If I were to have the fourth term in here, and that one is 45, you want to start with 36. And now how many times am I going to be adding 3? 1, 2, 3. 3 times. Hopefully you see the pattern. This number stays the same. So when we get to n, we're going to have 36. Hopefully you notice this number stays the same, but it wasn't written here. Could I write it like this instead? That way we have a 3 in every term, so the 3 stays. This is the number that changes. That's going to represent your n. Now how does this number relate to this n out here? So for the first term, this n is going to be 1 less. For this term, this n is going to be 1 less. Notice this one is always 1 less than the term. So this is going to be n minus 1, because we want this one to be 1 less than the one over here. This is our explicit formula. So what we do is we write this as a sub n. For any nth term, we're going to have 36 and add 3 n minus 1. That's going to be our explicit formula. Let's do a few more examples. What we're going to want to do for this one is write a recursive formula. So what we want to do is we want to start with a sub 1. A sub 1 is just going to be 1. So this is the first part of my formula. Over here I'm going to do the work to find out what my formula is in terms of a sub n. So a sub 1 is 1. A sub 2, what do I do to the first term to get the second term? Well, I take my first term, a sub 1, and I multiply by 1/2. How do I get a sub 3, this term here? Well, I take the term I had before it, and I multiply by 1/2. So I take a sub 2, and I multiply by 1/2. Here, to get to a sub 4, I take a sub 3, the third term in the sequence, and I multiply by 1/2. Hopefully we see the pattern. If this would be a sub n, this term, the term right before, is going to be a sub n minus 1, and we're going to multiply it by 1/2. So when we come over here and we write it, it would look a little better if the 1/2 came first. So we're going to write it with 1/2 a sub n minus 1. This is my recursive formula. It tells me where I start, then after that, I get my new a sub n based on what the previous term was in the sequence. Let's practice writing an explicit. This one would be challenging to write an explicit formula for, even if there is one. So make sure you follow directions and write the one you're supposed to. Let's do a new problem. Let's say we have 0.8, 1.6, 2.4, 3.2, and this was our pattern. This time we want to write an explicit formula. So again, remember to come up with the explicit formula. This is where we make our little chart, where these represent the nth terms in the sequence. Over here is what we're going to do to n, and on this side it's going to be our outcome. What do we get? So if I want to look at my first term, so for the first term in the sequence, I get 0.8. For the second term in the sequence, I get 1.6. For the third term, 2.4. For the fourth term, 3.2. So what am I going to get at the nth term? That's what I want to find out. So for this one, for my first term, I take 0.8, and if I don't do anything with it, I get 0.8. Okay? Or in other words, I can think of this as being multiplied by 1. If I take this one and I keep my 0.8 the same, how how many times am I going to have to multiply 0.8 to get 1.6? Well, twice. If I think about this one, how many times am I going to have to multiply 0.8 to get 2.4? Well, 3 times. And again, this one is 4 times. So if we go down, notice what number stays the same. We have 0.8 in every term. Then this number changes. What we have to do is figure out how this changing number relates to the terms. Are they the same or are they different? Well, these are the same. So for the nth term in the sequence, it's just going to be n. So you take 0.8 times n. So my explicit formula would be written as a sub n equaling 0.8 times n. This is my explicit formula. So next what we're going to do is I'm just going to list a bunch of formulas, and we need to determine if they're explicit or recursive. So let's try these. What we're going to do for this one is we're going to determine if this is explicit or recursive. So this one, because it just has a sub n and it doesn't have the previous term, this one's going to be explicit. This one here, is it going to be explicit or recursive? Well, this one doesn't have the first term, so this one also is just going to be explicit. This one has a first term, and then it has the a sub n over here, because it gives you the first term, and then the second one here. This one's definitely going to be recursive. So the big way to tell if it's going to be explicit or recursive is whether or not it's going to give you the beginning term. If it does, you definitely know it's recursive.